Okay, so in this integral we have r squared over r plus 4. Now it's telling us to use long division to evaluate the integral. The reason why we have to use long division is because the degree in a denominator, okay, is smaller than the degree in the numerator. So before we do anything, we need to first start out with long division. So now let's divide r plus 4 into the numerator, which is r squared, and then we're going to apply the missing terms. Plus 0r, which is the middle term, plus 0, which is the constant term. What do we need to multiply by r to get r squared? Well, that is r. So let's multiply it back through. R times r gives us r squared. R times plus 4 is going to give us plus 4r. Change our signs, and we get 0r minus 4r, which is negative 4r plus 0. So what do we need to multiply by r to get minus 4r? Well, the answer is minus 4. Let's distribute that. Minus 4 times r is minus 4r, and minus 4 times positive 4 is minus 16, and then we change our signs, and so therefore we end up getting 16 as our remainder. So the way we would write this answer is the following. We would say that the quotient is r minus 4 plus 16 over the remainder, which is r plus 4. So now we know that this is our new problem using long division. So let's go ahead and rewrite this integral. So we have r over r plus 4 dr, and now that's going to equal the integral of r minus 4 plus 16 over r plus 4 dr. Okay, and so now what we're going to do is we're just going to go ahead and then rewrite this with our separate integrals. So we have 1, we have a minus 4, and then we have the 16. So let's go ahead and write this out. So we have the integral of r dr so that's r dr minus 4 dr plus, factor out the 16, we have 1 over r plus 4 dr. And so now we're going to take the antiderivative of each one. So if we take the antiderivative of r, that's going to be 1/2 to the r to the second power minus 4r plus 16 times the natural log of the absolute value of r plus 4, and then that's plus c. And therefore there is our result.